Okay, I figured we'd go over some homework problems. Even though I'm giving you a worksheet today, I thought we'd take the beginning of class to go over some of the homework that you did last night. So I'll have Mr. Childs, or if one of you guys want to come up and read these answers, they're in the answer in the teacher's book, which is right up here. And you could read off the answers. You could read them all off, or you could just read off the even ones if you like. You know how I usually do it. But I thought I'd just go through, just pick a handful of them, figuring that you probably have a question on each section. So if you couldn't do a particular problem that I didn't go over, it's probably very similar to the ones that I'm going to go over. So let's start with the first little section. It says use a special right triangle to express each trig ratio as a fraction and as a decimal to the nearest 100th, to the nearest hundredth. I don't know if I haven't really made the instructions for the substitute just yet. Okay, I'll probably do it later tonight or tomorrow. This is actually Monday evening, and we're expecting some snow, so I don't even know it's going to snow tonight. They said 2 to something inches, so I don't even know if we'll have school tomorrow, but I'm doing this anyway. So here we go. Let's do let's see, it doesn't matter. Let's just do the first one, number 22. Alright, so let's do 22. And I'll show you what it's talking about. Oh, by the way, it says, I got off track. It said, and express it as a decimal to the nearest hundredth. I don't really care if you express it as a decimal. I'm looking for the fraction. That's the answers that I want. I really don't want you writing these as decimals. I want you to write it as a exact fraction, which means a simplified fraction, a reduced fraction. So make sure you reduce your fractions. If you have square roots on the denominator, I want them in the numerator, that whole thing. So maybe we'll hit one or two that does that. So here we go. Number 22 says the tangent of 60. And it says use a special right triangle to do this. So let's grab a triangle, put it right here. And it says tangent is 60 degrees. So what I'm going to do is I'm going to pick a triangle that's 30, 60, 90. Now, I don't know if this is exactly 30, 60, 90, and I don't really care. It's just to help us figure out how to do this. So let's call this one 30. Let's call this one 60. And of course, that's 90 right there. We want to find the tangent of 60 degrees. So if you remember from my lesson about the trig stuff, what is the tangent? Well, glad you asked. The tangent of the angle, we'll call the angle, make it look like a theta. Okay, we'll call the angle theta. The tangent of any angle is equal to the opposite over the adjacent. So I'm going to write this down just so we can remember it, since it's kind of new for us. So the tangent is the opposite over the adjacent. So we're finding the tangent of 60 degrees. So we're using this angle right here. So I'm going to do the opposite side divided by the adjacent side. So this over this. The problem is, I don't know what any of these lengths are, so I'm gonna have to call one something. All right, now this is a special triangle. It's a 30, 60, 90, so we know a relationship. We just talked about this last week, the relationship between some of these angles. So what we're gonna do, there's an example. It's example 2 in the book, page 563, if you want to look there. What they do is they make the shorter side, they just call it x. Remember, we said the shorter side is the one that's really important to know. So that's what I'm going to use. I'm just going to call it x. So if I call this x, I could actually find the lengths of the other two sides in terms of x, which means x is part of our answer. So what do we know about the hypotenuse and the short side? Well, the hypotenuse is twice as long as the short side, so that must mean this is 2x. Well, what about the longer side? Or the longer leg, we'll call it. The longer leg is the square root of 3 times the short side. So this would be the square root of 3 times x. So that helps us a little bit. So now we actually know some lengths of the sides of our triangle, at least in terms of x, all right? Because we have an x in all of them. Let's do this. Let's find now the tangent of 60. Remember, the tangent is the opposite over the adjacent. So we're starting with this angle right here, because that's the 60 degree. And so the tangent, let's write it like this. Actually, let's, since we had this in blue, let me grab the blue, and we'll do in blue. All right, so the tangent of 60 degrees is the opposite over the adjacent, the opposite of the 60. So the opposite is the square root of 3x over the adjacent. What's the adjacent side to 60 degrees? Well, it's the x. Let's simplify this. Well, look what happens. I get an x over x, so this cancels with this, and look what we have. We get the square root of 3. And that's the answer right there. I really don't want that as a decimal. Even though the problem says to write it as a decimal, I don't really want it as a decimal. So just keep it the square root of 3, and that's how you would do that. I'll tell you what, let's do one more. Let's do one with a 45 degree. All right. And this is already 45, 45, 90, because I think when I originally drew this, I made it isosceles. Alright, so this is 45, and this is 45. Alright, let's see which one we want to do. We already did tangent. Let's do another one. Let's do number 24. Alright, so 24 is the sine of 45 degrees. Let's do this in a different color. So we're trying to find what the sine of 45 degrees is equal to. So what do we have here? You could you can call this side whatever you want to call it. You could actually put just a regular number in here if you wanted to. It doesn't matter. Just like up here, you didn't have to call it x. You could have actually put a number in here. You could have made it 7 or 5 or 10 or anything like that, or 1 even. That would have been okay, because look, if you made this 1, what would this be? It'd be twice as big as this, so this would be 2. And then what would this be? This would be the square root of 3 times as big as this. So it would just be the square root of 3 times 1, which is square root of 3. And then if I did the tangent, it would be the opposite over the adjacent. It would just be the square root of 3 over 1, which is the square root of 3. So it really doesn't matter. This could be any number at all. So I could come down here if I wanted to. I could make this just a regular number. I can make it a 3, a 4, a 5, a 7, or 10, or 158 if I wanted to. I'm just going to make it x. So we'll call this x. Now remember, if it's 45, 45, these two sides are equal to each other. What's the relationship between the hypotenuse and either one of these legs? Well, it's the square root of 2 times one of the legs. So I want to find the sine of 45. Well, if you remember, the sine of the angle is equal to the opposite over the hypotenuse. Those are things you're going to have to remember. Remember SOHCAHTOA. SOHCAHTOA. Alright, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is the opposite over the adjacent. So we are going to use the sine, which is opposite over hypotenuse. Look, I can use this 45 or this 45. It doesn't really make any difference. Let's just use this one down here. So what is the sine of 45 degrees? Well, it's the opposite over the hypotenuse. So let's put this in here. So the sine of 45 degrees is equal to the opposite of 45, which is x, over the hypotenuse. The hypotenuse is the square root of 2x. Let's see what we can do here. This and this cancel out. Well, when I say they cancel out, they divide out. So what's left? If I divide this by an x, I'm left with a 1. So really, it's 1 over the square root of 2. But I'm not going to write it 1 over the square root of 2. If you remember, you can't have the square root on the bottom. So we've talked about this before. So you multiply the top and the bottom by the square root of 2, because that's really just a 1. And so look what you get. You get 1 times the square root of 2, which is the square root of 2, over square root of 2 times square root of 2 is just 2. So that is our answer. That's how I want you to write your answer. I don't want a decimal. I don't want the square root in the denominator. I want it looking like this. All right, so this is really the only acceptable answer that I'll take on a quiz or a test. All right, I think that's good enough for that first section. I did 2 out of the 6 that you had to do. So let's move on to the next section and actually solve for x. We're not just finding the sine and the cosine of an angle. We're actually going to solve for x. Alright, this is a very common problem with trig, with trigonometry, when you get an angle on one of the other sides and you have to find the other side. Now we could not use Pythagorean theorem here because I only know one side. This is not one of my special triangles, so I can't say this is twice as big as this or anything like that. Alright, because this angle right here is 21 degrees. It's not one of the special ones, so we use our trig function. Well, what I'm going to do is I'm going to mark this right here. This is the angle that we're dealing with. Now we could find this angle up here if we wanted to. We could go 90 minus 21, which is what, 69 degrees. I could make this one and use this angle here, but let's not. Let's just use the angle that they give us, make things a little bit easier for us. Now what we have to do is look at the other two sides. Look at the side that they give you and look at the side that you're trying to find. And what you want to do is you want to see, are they opposite? Are they adjacent? Are they hypotenuse? Okay, what is the relationship between those sides and this angle right here? If we know that, then we know what trig function to use. Well, let's take a look. Let's look at the 11 first. Here's 21 degrees. What is the 11 to this 21 degrees? Well, it's across from it. It's opposite. So we have opposite. Let's just write that down. So we have the opposite. Look at the x. What is that? Well, look, it's across from the 90-degree angle. So even though technically this side is adjacent to this 21 degrees, it's across from the 90, so we say that that is the hypotenuse. This side is always the hypotenuse right here. This would be the adjacent down here. This is the opposite, and this is the hypotenuse to this angle. All right, so what else do I have? I got hypotenuse. So what trig function do I use when I have opposite and hypotenuse? Well, let's list them out again. So it's SO, CA, TOA. And we got opposite and hypotenuse. Which one has opposite and hypotenuse in it? This one right here does. So which one do we use? We use the sine. So we use the sine of the angle. Hopefully you see that. That's not too hard, is it? So the sine of the angle is the opposite side divided by the hypotenuse. So that's the opposite divided by the hypotenuse. I'm going to get rid of this to give myself some room. Now, what we have to do is we got to solve for x. Now watch, this isn't too hard. You could cross multiply if you wanted. You could put this over 1 and cross multiply. This is what I do. Watch carefully. What I'm going to do is I'm going to multiply both sides by x. After a while, you don't even have to do this. You can just figure out what it's going to be. But I'm going to do it right now. I'm going to multiply this by x. Now if I multiply this side by x, I have to multiply this side by x. So look what happens. That cancels out with that. So what do you have? You got x times the sine of 21 equals 11. That's supposed to be equals right there. Now we have to get x by itself. How do we get rid of it? Well, we take the sine of 21, which is just a number. It's just a number that you put into your calculator, and you divide by the sine of 21. So you divide this by the sine of 21. And this is what you're going to put in your calculator. See, that cancels, x is equal to this. Don't circle it. I'm not really circling it. I'm just showing you, trying to emphasize it here. This is what you're going to put into the calculator. So let's do that. So it's 11 divided by the sine of 21, and that equals 30.69. We'll round it to 30.7. So that would be 30.7 what? Just the units. It's not degrees. Okay, we're not finding an angle. We're finding how long this hypotenuse is, and it's 30.7. Now this is perfectly acceptable. When you don't have a special triangle, go ahead and write your answer as a decimal. But if you have a 30, 60, 90 or a 45, 45, 90, I want your answers exact. This answer will not be exact. You can't really write this as an exact answer. You can only write it as a decimal, so that's what I'm going to accept right there. That's all there is to it. Let's do one more like this so we get the hang of it. Alright, here's another one. Well, they give you one angle. Again, you could find this angle down here, but let's just use the angle that they give us. It'll just save us from finding another angle. We don't really need to know this angle. We just have to use this angle. They give you one side, they ask for another one. So let's take a look. I'm using this. Let's look at the two sides, one they give us and one you're trying to find. Well, what's the one they give you? Well, it's either opposite, hypotenuse, or adjacent. Which one is it? Well, if you look at it, it's right next to this 63 degrees. See how it attaches to this angle right here? See how it touches right here? So it's adjacent to it. It's not the hypotenuse. Now you say, well, this is adjacent to it as well. Yeah, but this is the hypotenuse because it's opposite the right angle. The only thing that this is to this angle is adjacent. So what do we have? We've got adjacent. All right. What else do we have, or do we need to find? We need to find this right here. Well, what is this? We just said it a second ago. It's the hypotenuse. So look what I have. I've got adjacent and I've got hypotenuse. Which trig function uses the adjacent and the hypotenuse? Let's write them out again. So CA. I would do this every single time until you get used to it. After a while, you just know. But at first, if you're first learning this stuff, then I'd write it out every time. Which one has adjacent and hypotenuse? This one does right here. So what is that? That's the cosine. So I'm going to use the cosine of this angle. So the cosine of, oops, let's make that a little smaller. The cosine of 63 degrees is the adjacent over the hypotenuse. Which one is the adjacent? Well, it's 15 square root of 3 over the hypotenuse, which is x. The algebra is exactly what we did just before, just a few minutes ago. All right, so let's get the x over here on this side, but let's not go through all the steps like we did. let's think about this. I'm going to multiply both sides by x so it goes on top. Then what's the next thing I'm going to do? I'm going to divide by the cosine of 63. So that's going to go down here on the bottom here. So I could just write it like this. I know x is going to be on the top. I'm going to get rid of this by dividing by the cosine of 63. So that goes on the bottom. So look what I have. I've got 15 squared of 3 over the cosine of 63 degrees. Now it's just a matter of putting this, let's do it right here. Now it's just a matter of putting this into your calculator. So if you plug that into your calculator, let's see, you should get 57.2 approximately. It's not exactly. The decimals keep on going. We'll just round it to one decimal place. So we're good right there. So what did we just find? Did we find an angle? No, we found the length of a side. This side right here is 57.2. 57.2. That's the length of this side. Okay, on the last problem, I forgot to tell you, but the other problem was number 31. Hopefully you figured that out when you looked at the numbers and stuff. This problem right here is number 36. Okay? Again, you probably could have figured that out anyway. Well, let's do this. Let's go back to blue. This is a little different than what we did before. Before, we had to find the length of one of the sides. They gave you an angle, and you had to find one of the lengths of the sides. They gave you a length and you had to find the other length. Now look, this time, look what they're asking for. They're asking you to actually solve for an angle this time. Angle T. So I'm going to mark it right here, just so we can see it. This is the angle that I'm trying to find. Now I know it's a right triangle. This trig stuff only works with right triangles. So make sure that you have a right triangle when we're working with these, and we do. We're trying to find this angle right here. Alright, let's see what we can do. Look at these two sides right here. Let's find the relationship between these two sides and this angle that we're trying to find. When I say find the relationship, I'm talking about opposite, adjacent, hypotenuse. Alright, so according to this angle right here, what is this 8 to this angle? Now we have to relate it to this angle, right? Because it would be different if I'm relating it to this angle R. So to angle T, what is this side to angle T? Well look, it's across from it. Or it's opposite. So it's opposite angle T. If you want, you can write it down, just so you remember. It's opposite. What is side 12? What is ST? This side right here, what is it to angle T? Well, it's not the hypotenuse. Look what it is. It attaches to the angle that we're looking for. So this side attaches to this angle. So it's adjacent. It's not the hypotenuse because it's not across from the right angle. This RT would be the hypotenuse. This right here is adjacent. So I'm going to write down adjacent. Which trig functions uses opposite and adjacent? I'm not going to list them out this time. Okay, I've listed them twice, at least twice already. At this point, you start getting used to just looking and saying, oh, I've got opposite, I've got adjacent, oh, this is my trig function. So I've got opposite and adjacent. You can look back if you want at your notes and see what it is. Opposite over adjacent is tangent, so it's the tangent. Now this time, this is a little different because we're finding the tangent of an angle that we don't know. On those other problems that we did, I knew what it was. It was, one was 63 degrees, one was 21 degrees. I don't know what the degrees is for this angle, so I'm just going to call it T. Tangent of angle T equals the opposite over the adjacent. Well, the opposite is 8 over the adjacent, which is 12. You could reduce that if you wanted to. We're just going to use a calculator anyway, so I don't really see the need in reducing this. Now here's the tricky part a lot of people get confused about. Let's go to a different color. We're trying to find what angle T is equal to. And people that aren't used to trig will look at tangent and say, oh, we'll just divide by a tangent. No, you can't divide by a tangent, but we can do something to it. We can take the inverse of the tangent. Alright, so how do we do that? Hopefully, now I haven't taught this lesson yet because this is Monday and I'm teaching it actually tomorrow, which is kind of weird, so I'm trying to think ahead here, alright? But if we have school tomorrow, the tangent of T, how do I get rid of this tangent? I take the inverse of the tangent. So what I do is, if I take the inverse of the tangent, it goes away. But then I have to take the inverse of the tangent on the other side. So this is going to be T equals, now how do I write the inverse of the tangent? We write it just like this. That's the symbol for inverse of a tangent. Because anytime you take something to the negative first power, you're taking the inverse of it. So that's the inverse tangent of 8 over 12. Well, if you look on your calculator, you'll see a button that says inverse tangent. Tell you what, give me a second. I think I have a calculator. I might be able to pop up here real quick. Alright, I figured this out and got it to fit. We'll see how it goes. Let's see, I'm trying to find what t is. So I'm trying to take the inverse tangent of 8 over 12. This is how we do it on the graphing calculator. And I realize some of you guys have the TI-30s and that kind of thing. You do it a little bit differently on that. Unfortunately, I don't have a picture. I don't have like a working calculator of a TI-30. But I can explain it to you just kind of verbally. But let's take a look at this. A lot of you guys do have this calculator, so let's learn how to do it with this. It's the inverse tangent. If you look at tangent right here, see above it, it says tan to the negative first. It might be kind of hard to read, but when you look on your calculator, it will be very clear. So right above there, but look, it's in yellow, so I got to hit the second function. So I hit second function. That little up arrow says I'm getting ready to press something else. I'm on second function. Hit the tangent button. That actually gives you tan to the negative first. That's the inverse tangent. And then it gives you parentheses, and just like this, just like we're writing it out, 8 over 12. So it's 8 divided by 12. Put in your calculator. I don't think you have to close the parentheses, but I'm a little bit, I don't know, some people say I'm OCD. I don't think I'm quite OCD, but I'm a little particular. I just like to close the parentheses just to close it out. That's exactly what we have right here. Now when I hit the enter button, there I go. I've got an answer. So that's actually 33 point, we'll round it 7 degrees. So tangent, or t, not tangent, but t, angle t is equal to 33.7, and this is an angle. We're solving for an angle right here, so it's in degrees, and that's our answer. Now let me show you something that on some of you guys, your calculators might default to this. If you hit this mode button, you see all this stuff right here. Look at the third line down. Before I actually did this, I paused it and went through and practiced it, and my calculator was actually set on radians. You got to make sure that it's set on degrees. We'll talk some other time, maybe not even in this class, maybe in Algebra 2. You'll learn about radians and degrees. But for right now, in geometry, we're just going to use degrees, and so make sure your calculator is set to degrees. If you have a TI-30, one of the basic scientific calculators, it'll probably automatically default to degrees. This sometimes defaults to radians. See how it's in the first column? So make sure that you put it in degrees. Now how do you do that? You just click down like this. If I wanted to put it in radians, watch, I could hit that, I could hit enter, and it changed it to radians. See how it's dark right there? But I don't want it in there right now. I want it degrees, hit enter, and now it's in degrees, and now I'm good to go. Alright, if I clear it, I'm back to where I was. Alright, so that's how we do that in a calculator. Alright, here we go. This will be the last one that we do, and then I'll be quiet and let you guys work on your worksheet the rest of the time. Alright, so here we go. Let's solve for t. Solve for angle t. All these you had to solve for angle t. So let's mark that, angle t. And let's find our other two sides and find the relationship of these other two sides with this angle. I'll go a little quicker this time. So what do we have? We've got adjacent, we have hypotenuse. Adjacent and hypotenuse is cosine. So it's the cosine of the angle that we're looking for. So it's the cosine of angle t equals the adjacent, which is 3 square root of 2, over the hypotenuse, which is 7 square root of 2. Just to make this a little easier on your calculator work, look, square root of 2, they just go, don't they? Alright, so it just makes it a little bit easier for us. So now if I want to get t by itself, I have to get rid of the cosine. Now I don't divide by a cosine, I take the inverse of the cosine. So that'll go away. I have t here, and then I got to take the inverse of the cosine of the other side. Remember, whatever you do to one side, you have to do to the other side. So I took the inverse cosine here. I'm going to take the inverse cosine here. How do we write that? Cosine to the negative first of 3 over 7. Let's put that into a calculator. Okay, here's our calculator. So we have to hit the inverse cosine. So we hit second function, cosine, and then 3 over 7. 3 divided by 7. I like to close the parentheses, hit enter, and there you go. So t is equal to what? 64.6 degrees. That's all there is to it. Now, if you wanted to, if they asked you to find what r is, you could do trig stuff again, right? You could have used r as your angle and gone. Look at this one. If I would have gone and tried to solve for r, this would be opposite over hypotenuse, and I would have used the sine, opposite over hypotenuse, the sine. It'd be the sine of this over this to get this angle. Or if I already found Angle T, I could always just take it away from 90, right? Because these two add up to 90. 90 minus 64.6, and this would be this angle right here. Either way you do it, you could still find angle R. All right, well, I hope this helped, and I hope it helps you do the worksheet as well. So work hard on it, and tomorrow we'll go over some of the stuff that you had to do from the worksheet. All right, have a good rest of the day. We'll see you.